Hello class, today we are taking a look at some distance, speed, and time problems. In these problems, it's very useful to use a table to organize the information and to think about the relationships between the different pieces of information. And so for the first two problems on this handout, I've given you a little bit of a start on the table and filled in some of the information for you. So in question 1, we've got Katie leaves Calgary traveling north at the average speed of 60 kilometers per hour. 2 hours later, Brittany leaves on the same route traveling 100 kilometers per hour. We want to know how many hours did it take Brittany to catch up with Katie. And so when we set up our table, we want to talk about the speed of different people. We want to talk about the time that those different people have been traveling for. And we know the relationship of those with speed multiplied by time gives me the distance that those people have traveled. So let's take a look at our Katie and our Brittany. Since we want to know how many hours did it take, we're going to set the time that we've been traveling for as x. Now, if we take a look at our speeds, we know that Katie is traveling north at a speed of 60 kilometers per hour, and Brittany's traveling on the same route at 100 kilometers per hour. Now, those are the same route, so we could say that they're both positive or both negative. It's easiest if we say that those are both positive speeds. Now, since we're looking for how many hours, we're going to go ahead and set hours to be our unknown sort of variable. And so I've said that Katie is traveling for x hours. Since distance someone traveled is their speed multiplied by their time, I can take Katie's speed of 60 and multiply it by her time of x, and I get that her distance is the expression 60x. Okay. Now for Brittany, I know that Brittany was traveling at 100 kilometers per hour. I already filled that in, but I do need to deal with the fact that Brittany left 2 hours later. Now, if you left 2 hours later, you are traveling for 2 hours less time than the person who traveled for 2 hours earlier. So if Katie was x and Brittany is 2 hours later or less than that, Brittany is going to be x minus 2. 2 hours less than x, which is Katie's time. Now, in a similar way to before, we can take someone's speed, multiply it by their time, and we'll get our distance. So the expression for Brittany's distance is 100 times the time x minus 2. Let's go ahead and think about our comparisons. We don't have any comparison of their speed. I mean, we could say that Katie is a constant 40 less than Brittany. That's great. We used our comparison for time already. And the main thing that we want to know, the condition that we're dealing with here, is that we want Brittany to have caught up with Katie. Now, when you catch up to someone, you have to be in the same place. Right? Think about if you caught up to someone in a race, you could tag them on the shoulder. You've caught up to them, so you're in the same place. What that means is that Katie's distance has to be equal to Brittany's distance. So let's set that up. We're going to go ahead and say that Katie's distance is equal to Brittany's distance. And let's fill those in. We said Katie's distance was the quantity 60x. We said Brittany's distance was the quantity 100 times x minus 2. Let's now solve this equation. First step in solving any grade 9 equation is to expand brackets. So 100 times x is 100x, and 100 times minus 2 is minus 200. Next step in solving any grade 9 equation is to collect your x's so that they're positive. Since we have x's on both sides of the equal sign here, I'm going to cancel the x's with the smaller coefficient, which is the 60. The opposite of positive 60x is to minus 60x from both sides of the equation. 60x minus 60x leaves us with 0 on the left side of this equation. 100x's take away 60x's gives me 40x's, and I still have my constant minus 200. Undo that subtraction. The opposite of subtracting 200 is adding 200. We get the new equation 200 is equal to 40x. And we'll finish up by undoing that multiplication by dividing both sides by 40. 200 divided by 40, I can use my calculator if I need to for that. And of course I get 5 as the value of x. Now, if we go ahead and we think about our solution, x was originally the time that Katie has been traveling for. And so we could say that Brittany will catch up to Katie after 5 hours. Now, we could be a little bit more specific here and say 5 hours after Katie left Or alternatively, you could realize that, okay, well, if it was 5 hours after Katie left and Brittany left 2 hours later, we could say 3 hours after Brittany left. So it might be a good idea to just be specific about, these hours, given that we could be talking about that Brittany's been traveling or that Katie's been traveling. Okay, in question 2, we have two cyclists leave an intersection at the same time and they travel in opposite directions. That's going to be important to us in just a moment. Bob is traveling at 20 kilometers per hour and Sam is traveling at 60 kilometers per hour. We want to know how long will it take for the two bikes to be 240 kilometers apart. Now, it doesn't say anything about the cyclists leaving at different times. In fact, it specifically tells us that we are leaving at the same time. And so we've gone ahead and said that, well, both of them are traveling for unknown time x, and we do want to know how long that took. So that's going to be our variable. Now, we said that Bob is traveling at 20 kilometers per hour, so we've put his speed as plus 20. Now, we did also say that they're traveling in opposite directions, and Sam's traveling at 60 kilometers per hour. So if Bob is in plus 20, Sam's definitely doing 60, but he is doing negative 60. E-bike or maybe a motorcycle, I guess, if he's doing 60 kilometers per hour. That would be a pretty fast bike ride. But the key here, of course, is that since they're going opposite directions, if Bob is positive, then Sam has to be negative. Now that we filled those in, we can fill in what their distance would be. Each of their distances is just their speed multiplied by their time. So in this case, Bob's speed of 20 multiplied by the time x gives me 20x for their distance. Sam's speed of negative 60 times their time of x gives us negative 60x for their distance. Okay. Now for our equation, the key idea is that we want the two bikes to be 240 kilometers apart. So when we subtract their two distances, we should get an answer of 240. So let's go ahead and do that. We're going to take Bob's distance, and we're going to subtract Sam's distance. Maybe we'll use D here just to make this fit a little bit nicer. And when we subtract those two, they should have a difference of 240. They're 240 kilometers apart. Okay, let's go ahead and fill in. We said Bob's distance was represented by the quantity 20x. We want to subtract Sam's distance. Sam's distance is the quantity negative 60x. The difference of those is going to give us 240 kilometers. So let's go ahead and do this. Now remember that when you subtract a negative, a rule for subtracting rational numbers is to add the opposite. So we could treat this as plus positive 60x, and 20x's plus 60x's gives us 80x's in total on the right side when we collect those x's. To finish solving, we're going to go ahead and undo this multiplication. The opposite of multiplying x by 80 is to divide. 240 divided by 80 gives me, 10 divided by 10 gives me 1, and 24 divided by 8 is 3. So I could say that x is 3. And we could say they're 200 kilometers apart after 3 hours. We don't need to specify for Bob or Sam 3 hours because, of course, they are traveling for the same amount of time. Okay, so these problems here, it's very helpful for most people to set up their information in a table, right? Give some information for each of the people or each of the options, and also kind of look for any of those comparisons that we might have, okay? Hopefully that's helped you with your distance, speed, and time problems.